This video will demonstrate how to configure a Copley Controls Xenus Plus EtherCAT servo drive for use with a Galil EtherCAT motion controller. We will use the Copley Controls CME2 software to configure the Xenus drive. Be sure that the drive is powered on and connected to your computer's serial port. Open the CME2 software. If the software does not automatically connect to your drive, use the Communications wizard under the Tools menu to configure your communication settings. First, let's ensure that the amplifier setup parameters are correct. Click on the amplifier setup icon on the main toolbar. This will open a summary of the amplifier setup. To walk through all the settings, click on the Change Settings button. I am using a brushless rotary servo motor. My motor has digital Hawes and incremental feedback. The encoder is 1000 lines or 4000 counts post quadrature. I am not using a brake. The operating mode should be set to position, and the command source should be set to can open over EtherCAT. Leave the miscellaneous settings at their default values. Click Finish, and then click OK to save the amplifier settings to the drive's flash memory. Next, we will configure the I/O settings. Double-click on Input/Output to open the I/O settings. Set Input 2 to high-speed position capture on high-low transition. The rest of the inputs should be set to not configured. This table shows how the drive's inputs are used with a Galil controller. Now we need to enter the parameters for the motor we are using with the Xenus drive. Double-click on the motor icon to open the motor settings. Enter the specifications for the motor you are using, or open a motor parameter file that was previously saved. Click on the calculator icon. The software will calculate the initial tuning parameters based on the motor data that was entered. Click OK to save the motor data to flash. Note this will only save the motor data. It will not save any changes made to the amplifier settings. Finally, we will calibrate the motor for commutation using the CME2 auto phase feature. Click on the auto phase icon on the main toolbar. The first step is motor direction setup. Move the motor shaft in the direction you want to be positive. Click Next when done. Second is motor wiring setup. Press Start to begin the motor wiring setup. The software will microstep the motor. During microstepping, a current vector is applied to the motor windings at a set rate, causing the motor to move. Once the motor wiring has been configured, click Next. Next is the phase count test. Click Start to begin. This test will ask you to visually confirm that the motor shaft makes 1 revolution. If the motor made 1 full turn, click Yes. Then click Next. The last part of autophasing is the Hall wiring setup. Click Start to begin the test. The software will microstep the motor, and as the motor moves, the Hall lines are decoded for proper commutation. Once the test is complete, the motor has been phased properly. Click Finish. Click the Save to Flash icon on the main toolbar to save all the amplifier parameters we have updated to the drive's memory. We have now completed the setup and configuration of the Xenus drive. Now we will use the Galil GDK software to initiate the EtherCAT communication between our DMC 50000 and the Xenus drive. In GDK, open a terminal window. Issue the command MO to ensure all the motors are off. Issue MT10 to set up axis A as an EtherCAT axis in cyclic position mode. Issue EX-1 to map axis A as the first EtherCAT axis on the line. The EX command configures a specific axis for use with an EtherCAT drive at the designated station ID or line position. Issue EU1 to bring up the EtherCAT network. Now let's open a viewer in GDK so we can see some more information on axis A. With the EtherCAT network running, the DMC is now in complete control of the Xenus drive, just as if it were a local access on the controller. I will demonstrate by enabling the drive and commanding a simple jog move. Thanks for watching. Please contact us if you have any questions.